right, so we're doing this video on a request here. It's an integration power rule video, and basically we're going to talk about fundamental antiderivatives and how to arrive at them. So first things first, let's consider that integration is the opposite process of differentiation for all intents and purposes. Meaning, if f prime of x is g of x, that means the f of x is the integral of g of x dx. Okay? And let's consider the power rule for differentiation. So let's say f of x is 5x cubed plus 2x squared plus 7x plus 5. We can differentiate this pretty easily using the regular power rule here. It's 15x squared plus 4x plus 7 plus, well, 0. We don't have to account for that. So the way we do that is we have, say, an f of x that is x to the n, and we multiply by the power, and then subtract 1 from the power to get the f prime of x. So to do the inverse process, we're going to do the opposite steps. So here we multiply by the power and then subtract 1 to get the new power. So if instead we're integrating x to the n dx, dx, by the way, for our purposes, basically just means that we're integrating as a function of x. Until you get to multivariable calculus, it's important to put, but it doesn't really change. Most of your problems are going to involve, d of whatever variable you're doing, dx, dt, whatever it might be. So here, let's do the opposite steps. We're going to do them in reverse order as well. So we're going to add 1 to get the new power. And then instead of multiplying by the power, we're now going to divide by it. So, in a nutshell, this is the power rule of integration. X to the n plus 1 over n plus 1. And we could do this with this example that we have here. If I were to integrate 15x squared plus 4x plus 7 all dx, well, let's do that. We're going to do 15, because that's a constant, x cubed over 3, plus 4, this is x to the 1, so it's now going to be x squared over 2, plus 7. Now this is technically x to the 0, so now it'll be 7x to the 1 over 1. You could also just remember that the antiderivative of a constant dx is just cx. Now, it's also important that we put a plus c here, because no matter what this constant here was, this 5, it would always derive to 0. So we would never have that there. So in theory here, this c can be any constant. And then, of course, we can go ahead and simplify a little bit here. 15 over 3 is 5. 4 over 2 is 2. 7 over 1, well, it's 7. I guess I could have just left that there. And we get 5x cubed plus 2x squared plus 7x plus c. And again, that c can be anything. There's some initial conditions. We'll cover that in a different video. So let's do a couple of examples. We're going to start with the easiest one here. It's just f of x is 3x plus 6. Again, I'm just going to put the little 1 here for notation. So we're going to integrate all of these. I wrote them all as functions. The question here is we're going to integrate here. Okay. So we're going to change that power from a 1 to a 2 by adding 1, and then divide by 2. And this is really x to the 0, or you could remember the rule that that's just going to be 6x. And don't forget your plus c, and that's your integral. If you were to derive this, you will get the original answer back. Now let's take a look at the second one here. We're going to go ahead and integrate 4x to the 6th minus 9x squared. Now, to make this work a little bit easier for us, what I'm going to do is I'm going to rewrite the x to the 4th as 1/4 of x. Because I'd like to isolate those variables and get the constant to the outside. It just makes it a little bit easier to see, at least in my mind. So let's integrate this. I'm always going to try to get every term as ax to the nth power, okay? Because that makes it much easier to integrate than that will, integrate to ax n plus 1 over n plus 1. Again, that's a matter of preference. You don't necessarily have to do it that way. So let's do this one here. We're going to add 1 to the 6, make it 7 divided by 7. We're going to add 1 to the 2, make it 3 divided by 3. We're going to add 1 to the 1 and divide by 2. And we're going to just use our constant rule here to write this as 8/9 of x. And again, don't forget our plus c. And the next step is simply to simplify whatever you can here. The 4 and the 7 don't simplify. This does. These multiply to an 8. And our final answer is 4/7 x to the 7th minus 3x cubed plus 1/8 x squared plus 8/9 x plus c. And you'll note I wrote this one as a fraction times the power. Over here I wrote it all, and it's the same thing. 3x squared over 2 is the same thing as 3/2 x squared. Right? Let's move along here. I'm going to use the same concept here to rewrite this as a function of all powers. So for this, we need to remember that the square root of t is t to the 1/2, and the cube root of t is t to the 1/3. And we can remember this using this property, x to the m with an index of n is x to the m over n. We're going to see a couple more of those applied in the next problem as well. So here this is going to be rewritten as t to the 1/2 plus 3t to the 1/3 dx. And the process other than that is exactly the same. So we're going to add 1 to the 1/2. That's 3/2, and we can use common denominators to find that. And then I'm also going to add 1 to the 1/3. Okay, 1 is equivalent to 3/3, so we add them up, we get 4/3. So now this is t to the 3/2 divided by 3/2 plus 3t to the 4/3 divided by 4/3 plus c. Now to make this a little bit easier here, dividing by a fraction is the same thing as multiplying by its reciprocal. So now we're left with 2/3 t to the 3/2 plus 9/4 t to the 4/3 plus c. And that's that. Finally, one more step. One more problem, rather. So we have 3 over the square root of x. Now, we also need to remember that 1 over x to the n is x to the negative n. So 3 over the square root of x is 3 over x to the 1/2, which is 3x to the negative 1/2. We always want to get it into that form of a constant times x to a power. Okay, the next one here is 12 over x to the 2/3 using our index rule from before, which is 12x to the negative 2/3. Minus 4x plus x cubed dx. So same process. Now we get rid of this integral sign because we're now actually doing the process of integration. So this is going to be 3x. Now negative 1/2 plus 1 is positive 1/2. It's negative 1/2 plus 2/2. Divided by 1/2, or as we established, that's the same thing as multiplying by 2, but I'm going to write it out this way first. Plus 12, x to the, now negative 2/3 plus 1 is negative 2/3 plus 3/3, so that's 1/3. And again, divided by 1/3, which we will change to times 3. I'm just writing it out to show every step here. 4x squared over 2, x to the 4th over 4 plus c. Now all we have to do is simplify the problem. Multiply this by 2, multiply this by 3, reduce these to 2, and that's it. We get 6x to the 1/2. Now we will change that as well to a radical. Since we were given a radical, we should give it back in a radical. And again, it doesn't really matter if you write it this way or this way in this case. So this answer is technically correct already, but since we were given radicals in the initial problem, I'm going to give them back in this case. And that's it. We hope you find this helpful. If you like this video, you found it helpful, please subscribe to our channel and check out some of our other work. And again, feel free to email us. Our information is in the video info. I'll be happy to create something explaining a topic that you need help with. Thank you very much.